Hi ladies, in this video we're going to go through 6H, fractional indices and surds. So basically surds are you using the square root sign or the root sign, because you can have a cubed root, fourth root, fifth root, etc, etc. So in this table here, I thought I would just use it to show you how fractional indices also relate to surds. Okay. So 2 to the power of a half is the same as the square root of 2. So when you see, I have to write this over here, half is the same, oops, sorry, let me just started and I've already made a mistake. Okay, so a base to the power of a half is the same as taking a square root to that base. So here we've got 2 to the power of a half is the same as the square root of 2. Now, what it's basically saying here is if you put that into the calculator, are you going to get a whole number or a decimal? So for the square root of 2, and I can't write on that, which is annoying because it's on the, not on where, go away. Sorry, I'm not going to touch it. Okay, so you'll get a decimal. Is it a surd? Yes. It's a surd because it doesn't simplify to a whole number. Now let's look at 4 to the power of a half. So 4 to the power of a half is the same as the square root of 4. Now the square root of 4 will give you 2, which is a whole number or an integer. Is it a surd? No, because you're given a whole number. All right, then we've got 11 to the power of a half. So you might already know what that is, the square root of 11. Do you get a decimal? Yes, you do. So that's not a perfect square underneath the square root sign. And if we look at 36 to the power of a half, so the square root of 36, if you put that onto your calculator, you would get 6. So it's not a surd because you get a whole number. So if you have a perfect square under your square root sign, so the perfect squares are, well, let's start with 1. So 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, 6 squared is 36. Then we've got 49, 64, 81, and 100, and they keep going. Okay, but I'll just stop there. So if you had a square root of any of these numbers, you're going to get an integer, a whole number. So it's not a surd. So if we look at, now we're going to look at 1/9 to the power of a half. So let's just do that over here. So 1/9 to the power of a half. Now, remembering our index laws, that half applies to the 1, the numerator, and also to the denominator. So we're effectively taking the square root of 1 over the square root of 9. Now the square root of 1 is 1, and the square root of 9 is 3. So 1/9 to the power of a half is the same as 1/3. So is it a surd? No, it's not, because we don't get a whole number. We can get a fraction. Okay, so we don't need to leave it in surd form. That's interesting that it had a decimal there. It's kind of mixing things up. So it is the square root of 9 does give you 3. So it isn't a decimal, but 1/3 is a decimal. All right, we do call them rational or irrational numbers. So if it can be written as a fraction, it's a rational number. If not, it's an irrational number. And also it's irrational, but that's another thing for another day. All right, let's just do 1/10 while we're here. So I'll point 1, so 0.1. Now, in a previous video, I was saying it's better to convert things into fractions, a lot easier to work with. So there's 1/10 to the power of a half. That's the same as the square root of 1 over the square root of 10. Square root of 1 becomes 1, and then on the denominator, we have the square root of 10. And we just leave it as square root of 10 because 10 is not a perfect square. All right, now this is where you need to remember fractional indices. So the next one we've got 3 to the power of a third is the same as the cubed root of 3. You'll get a decimal and it's a surd. Okay, let's look at, and then 15 to the power of a third. I think that next one should have been an 8. Just notice that. Cubed root of 15 for that. Now, let's have a look at 1 over 27. So this one we can actually simplify, oops, to the power of a third. So we have the cubed root of 1 on top and the cubed root of 27 on the bottom. So basically the cubed root is saying what number multiplied by itself 3 times gives you 1? Well, it's just 1. And the bottom, what number multiplied by itself 3 times gives you 27? So that is 3. Now 3 cubed gives you 27. So the cubed root of 27 is like the inverse, the opposite of it. And then 5 to the power of a quarter is just the 4th root. So I'm running out of space on my page to write that. So 5 to the power of, oops, the quarter is the 4th root of 5. And then 64 to the power of 1/6 is the 6th root. So what number multiplied by itself 6 times gives you 64? And it's actually 2. So that is not left in surd form. Okay, let's just keep scrolling. So you can see the key ideas here. So your fractional indices, so a to the power of 1 over m can be rewritten as m root a. So m root a. Don't say the square root unless it's 2. So if it was a 3, we usually say the cubed root, or 4, 4th root, 5th root, etc., etc. And we don't tend to write 2 root. Okay, if it was just the square root, you don't write the 2 there. All right. So surds, as I said before, are rational numbers written with a root sign. So basically, irrational numbers can't be expressed as a fraction. So your decimal numbers keep going on forever. The decimal, and they're not recurring. There's no pattern. Oh yeah, there we go. That's what the next point says. So it's infinite and non-recurring with no pattern. So your decimal places keep going, but there's no pattern in that. So if you think about 1/3, that keeps going 0.33333 on forever, but that's a pattern. Okay, so the 3 keeps going, so you can represent it as a fraction. All right, so let's get stuck into some questions. So first question, very easy. So we'll quickly get through some of these. So 8 to the power of a half can be rewritten as the square root of 8. Now, we can simplify surds, but we're not going to do that right here. So the square root of 8, just like we can simplify fractions, we can simplify surds, and we can actually simplify the square root of 8, but we're not going to do that just yet. That'll be coming up very soon. 15 to the power of a half is the square root of 15. B, so 3 to the power of a quarter is the same as the 4th root of 3. Okay, so question A is very similar to question B. I'm not going to do, sorry, not B. Question 1 is the same, very similar to question 2. Okay, so you're just using those square roots. All right. Now, question 3 is now the opposite of that. So question 3, we're being given the surd and we've got to use it with in index form, write it in index form. So square root of 8, which we had up here before, is the same as 8 to the power of a half. 4 root 8, so let's look at E. Sorry, 4 root 5 is just 5 to the power of a quarter. Okay, so just doing the opposite. Now, question 4, you can go on and evaluate, and it says without using your calculator. So this just requires you to think a little bit. So let's start with an easy one. So 4a, 25 to the power of a half. If it helps, you can rewrite it as the square root of 25, which is 5. Now, some of you will know that you actually get 2 solutions here. You get both positive and negative 5, but I'm happy with you just writing the positive answer for now. But basically 25 you get from doing 5 times 5 and negative 5 times negative 5. So often when we take the square root of a number, we get 2 solutions, but we're just going to look at the positive solution for now. All right, let's look at question E, 8 to the power of a third. So that's the cubed root of 8. So basically we're going to say, well, what number multiplied by itself 3 times gives you 8? So if I was to just write that in expanded form, it's 2 times 2 times 2. If you want to know how to get that, you can do a factor tree, your prime factor tree. So 8 is the same as 2 times 4 and 2 and 2. So you're basically, you keep going down this path until you get your prime factors. So if you're a bit unsure what it could be, you could break it down this way. So the cubed root of 8 is just 2. So what number multiplied by itself 3 times gives you 8. So you're doing the opposite. Let's have a look at maybe a harder one. Let's do 81 to the power of a quarter. So J, 81 to the power of a quarter. So that's the same as the 4th root of 81. You kind of, after doing a few of these, you'll know roughly what it is. So I look at this and I'm like, oh, it's got to be 3. And then I just do it in my head to check. But if not, just write 81. Do some factor pairs. So I know 9 times 9 gives me 81. It doesn't matter what factor pair you use, as long as it's not 81 and 1. And then break them up again until you get all your prime factors. Okay, so we've got 3. So the 4th root of 81 is 3. Okay, so what number multiplied by itself 4 times gives you 81? And that is 3. Now, if you think about just here, 81 is the same as 3 to the power of 4. And what I am basically doing here, 81 to the power of a quarter, is the inverse of this. Okay, so you're thinking, well, what number multiplied by itself 3 times gives me 81? Okay, so you're doing it the opposite way. So instead of doing 3 to the power of 4 gives you 81, you've got 81 and you're going to say, well, what number multiplied by itself 4 times gives me 81? So it's 3. Sometimes I talk and I don't know what I'm saying, so sometimes I think, am I making any sense? Let's do one more. Okay, let's look at K. Okay, so we've got 625 to the power of a quarter. So that 5 on the end kind of gives me a hint as to what it might be. So I'm going to think, well, is it 5? So another way you could do it, instead of doing like a prime factor tree, you can say, well, what does 5 times 5 times 5 times 5 equal? Because that's effectively, you want to get 625. You're looking for a number when multiplied by itself 4 times gives you 625. 5 times 5 is 25. Then we're going to multiply it by another 5, gives you 125. And then we're multiplying that by 5, gives you 625. So sometimes doing a little bit of working out on the side can help. So your answer for that one is 5. All right, let's give us some space for next question. So question 5. So we've got a to the power of a half times a to the power of a half. So remember, when you're multiplying the same base, the base stays the same and you add your powers. So a half plus a half is 1. So that answer is just 1. Oh, not 1, sorry, a. Let's make it look like an a. Let's do question E. So we've got x to the power of 2/3 over x to the power of 1/3. So remember, when we're dividing your powers, you subtract your powers. So that 1/3 you just take away from there. So it's going to be x to the power of 1/3. And it says to leave in index form, so we're just going to leave it as x to the power of 1/3. But that is the same as the cubed root of x. All right, let's do one more. Oh, excuse me. Let's do m. So we've got x to the power of 2 over 3, all to the power of 4. So using your knowledge of index laws, these are multiply. So it's going to be 2/3 times 4. So that's 2 times 4 gives you 8, so 8 over 3. So x to the power of 8 over 3. Now, if you were to write that in surd form, okay, that's the same as writing, you can separate the 8 and the third, so it can be, 8 to the power of 1/3. So you can do the cubed root of x to the power of 8. Same thing, okay? And there's many ways you, well, not many, but there's a few ways you can interpret that. But the first question, the question is asking you to write in index form. Sorry, I'm not making much sense because I've got a real tickle in my throat and it's annoying me. All right, so that's it for this video. In the next one, we'll go through some difficult questions. Oops, I just realized I should have put a square around that. That's your final answer, not the next one. All right, thanks guys, bye.